Okay. So now we'll think of like how the traditional RAG works, right? So we already discussed. So in our previous chapter, we already discussed about what exactly the RAG is, how the RAG architecture looks like, and what is the workflow of the any RAG system, right? So now we'll get little more into like how the traditional RAG system look like. So when we are talking about traditional RAG, right? This type, let's take a modular approach in the sense like some object-oriented programming based approach, right? To build a RAG system by encapsulating different components of RAG in the sense like, okay, retrieval and generation into one class and augmentation into another class, right? I mean, it's kind of, building the traditional RAG system in a way that we write in our program, right? So the first, what we shall start with a small data set that's about 18K vectors. So that you can try it hands on even on personal computer also, right? So let's not go with a higher vector size, so we can able to do that. But for that, we have to go through two different stages. One is the data preparation, other one is the data set embed, right? So embedding the data set, whatever the data set we have prepared, so you have to embed those data sets, right? So you can say it's a kind of preparation of the data, getting the data, collecting the data, and then we are embedding those, on whatever the data we got, right? So in this case, what we can do? Okay. So the first and foremost is like, while you are trying to prepare the data set, okay, before diving into building the RAG system, we first need to prepare a data set, right? So what we can say, like we'll use here what we are trying to do. We'll use the squad data set, like the Stanford question answer data set, right? It's a pre data set available in the internet. So we're going to use that, which contains questions, context, and answers as well, right? So while the full data set includes tens of thousands of entries, we'll only gather the context and embed them and then store them into the vector database. Okay. So if you see this, since the context is the only thing we have to rely on, a knowledge base, right? Context, like, see, the point is like whenever we are talking to one of our friend and asking about something, or discussing more about some topic, then what we should have the knowledge about that particular context what we are talking about. Let's, for example, we are talking about some politics, right? Like how politics works and what are the different politicians and how they are working. If if one of the friend is not more keen about the politics latest news or something about that, then how they will continue the conversation? It's not possible, right? Only one person is only talking about, and the other person is just say yes, 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 oh yes, yeah, maybe, yes, maybe, something like that, right? Because the other person doesn't have any idea about what is the latest politics news going on, right? And what are the things happening. Or maybe you can say talk about a new tech stack. The other person is understands like what is the AI and all, and the other friend is really doesn't know about what exactly the AI system going on nowadays, right? So it's difficult to continue the conversation. So that's why you call as the knowledge base. The context is nothing but the knowledge base on which the whole system relies on, right? So that's why you will only take the context into the consideration while we are for the embedding purpose, right? So if you see here the code itself, right? So here we are trying to load the data from the square, right? So before so here while we are trying to write the code for from data sets input load data set, right? So, well, to understand this code base, you need to understand you need to know the Python, how to write Python, right? So here, while we are trying to import some data, I mean, some library from, some classes from the library, that library has to be installed beforehand, right? So that is called pip install, install dataset, right? We are trying to install the dataset first, the library first, then from the library, we are trying to import the load dataset class, right? So and we have to call the load dataset class and pass the squad itself, right, into it. Then in step 2, what we are trying to do, we are trying to extract the unique context from the dataset. That means we are trying to, trying to loop through or iterate through the items we have in that particular train dataset as train dataset, right, and get the context itself, right? Because it has the context, it has, as we discussed, like it has context, it has questions, and it has answers. So what we need is only context, right? We are trying to load the context. Now we are storing that as a text, right, into that. It's a simple programming. Like now the text look like this, right? So if you see the text here, what exactly it's trying to say. Now what we did, so in this data set, if you see, like each context has multiple different questions and answers in pair, right? So that's what we got is like, if you see here in this picture, right? So we got the context. So every context has number of questions, answers, and their context as well, right? So that's what it is. So now we collected all the context from the data set. In this particular context, right? So if you see, the context itself is read out in Ireland comprehensive schools, where an earlier model of state schools introduced in the late this guy, blah blah blah, all these things. It's related to the actual information. Let's think of like this is a subject we want to talk about, right? Now, first we have to store this. We got this context. We have to store this context in our data store, right? And a vector store. So before that, what we have to do? We have to embed this data set. This data set we got, we have to embed this and store it into. So we have the context one, okay, and we have context two. We got two contexts, right? So one context is, we have applied the embedding model and we embed it, and then context two also embed it. So now what exactly we are doing? Now, we got the data sets. We need to create its embeddings. So in this case, we shall define an embedding on context level. So that is each element of the above texts, right? The text we saw in our previous slide, right? We collected as a context. So list will be embedded into a single vector, right? So here, what we are trying to do, like, so what we will do, we'll encapsulate this functionality into into some class called embed data or something like that, right? So what we will do, let's see. So here we'll try to create one class called embed data, right? Embed data. So in this embed data, what we are trying to encapsulate, we are trying to encapsulate uh, first things like the loading the data, right? The we already loaded the data in our previous the previous program, right? And this class we are mostly trying to load the embedding model, right? So in embedding model, any embedding model you are using, you can create the instance of that particular embedding model, then provide the methods to batch process. Okay, batch process is the data set for efficient embedding generation, right? So if you think of what embedding model you are using here, so nomic embedded text v1.5, right? So and batch size is 32, right? So whatever the number of text text we have, so it will try to embed batch by batch. Okay, so every batch size we are giving 32 in 32 32 text in the batch itself, every batch, right? Now we are providing we are getting the model name, and then we're loading the model itself, all these things. So we are creating a data model for that, correct? So now we are trying to store the generated embeddings for use in the retrieval system, right? So what is the retrieval system? Is nothing but a data store, right? The vector store. So first, we have defined the embed data class, and then initialize those embedded names, right? The model name, and then the batch size, and we have started building creating the instance of those methods, right? So here, what exactly the self dot embed, if you see that self dot embed that model name, right? The model name is doing. It actually stores the embedding model's name for the reference, right? And the next one is embed model. So this will store the embedding model written by a method. I mean, we'll define shortly, and that will be that will load the embedding model and return it, right? So that's how this is the method we are calling to load it, right? And the batch size, we know the batch size. So this is the this is the size where it specifies like each batch for embedding. Whenever the embedding starts, for every batch, how many number of what is the size of the batch it will go and embed, right? And the embeddings is the list of whatever the when it's embedded, then it will try to store somewhere, right? So we are using a list to store the generator embeds, right, for the time being. Okay, so that means in memory embedding storage, right? It's not vector store. So now what we'll do, the next thing, what we are going to do, the next thing here is like, while while we are trying to create while we are trying to create embed data, right? We are also using the cache folder, right? The cache folder is nothing but you're trying to cache the model, right? Cache the embeds, whatever you are created as a cache store, not actually a vector store. That means we are not using any single store vector DB or any other vector DBs, right? There are a lot of vector DBs, but you are not using vector DBs here, right? That's what I'm talking about. Like we are using the cache as a storage, right? For storage, and we are using the Hugging Face embedding, right? The model is nothing but the Hugging Face open model, right? So, so here, what we are trying to, we are specify local folder, that is the HF underscore cache, right? Uh, to cache the model for future use, right? So that we don't have to again and again re-download that particular model, right? Because that model is available in Hugging Face site, right? Uh, you have to download every time and run it. Rather, download once, store it in a cache folder, and then reuse that again and again whenever it's required, right? So that's where we have written here like embed model equal to Hugging Face modeling, Hugging Face embedding, the model name, and then model name we have already defined uh, in our above program, right? And then we are trying to put it the trust remote code. It will always trust it, and then we are using the cache folder, right? So that's what. And next, what we are trying to do, right? Next, we'll do is like initializing, right? So we have already defined the init function in our previous slide, right? And we also defined the load embed model. So now we'll try to define the generate embeddings, right? So in the generate embeddings, what exactly we are trying to do? We are returning the text embedding batch, right? Whatever the embeddings we generated out of the context, we are trying to return it. So this guy, we are getting this particular function to call this particular function to get the embeddings from the context, whatever we are going to generate, right? So now the context parameter, if you see the context parameter here is a list of passages, right? We saw earlier, right? If we go back a little bit, the text. So these are the text is work like a context in that to that particular function, right? See this to this particular function is a context, right? So now the method accepts the list of list of context and returns a list of embedding using the get context batch, right? So that's how the function here. And finally, what we are trying to do, we are trying to iterate the batch itself. So we are trying to iterate the batch and create batch and passing that batch to that particular function. If you see here, right? So here we are trying to call that batch iterate, and then whatever the batch we are getting, for every batch, we are sending it to a embedding process, right? So that's how we are trying to do here. Finally, we have an embed and then embed method that orchestrate the embedding process for all context by batching the process and invoking the generate embedding method for each batch we have iterate here. The iteration here for each batch we are calling that, right? So that's what the whole process we are going with. So here if you see this one, right, the embed data batch size. So batch size is and then embed data dot embedded actions, right? So that's what the whole thing is going. So now once all this has been generated, right, and we got the embeds, all these things, now that's got stored, right? That's how the I mean it's stored in our storage, and now we are able to query anything whatever we have stored now, right? We embed now, right? Thank you so much. You haven't subscribed yet, please subscribe, and I'll try to make sure like I'll put more and more fundamental things to understand deeply the basic level, the base level, the fundamental level of the AI and Gen AI, so that you can really progress through your future career in Gen AI. Till then, take care.